Hi, welcome to the pre-calculus lecture series. And in this video, we're going to we start a new chapter. It is chapter 7. So we call this analytical geometry. So basically, we're going to take a look at a lot of the formulas based on the trig functions here. So in the section 7.01, this is the first video we're going to talk about some very basic trigonometry identities. You probably already experienced some of them when we did the previous chapters here. So for this chapter, we're going to cover a lot of the formulas about the trig functions here. Okay, so let's go ahead and start some very basic identities. Okay, so let me go to our lecture notes here. Okay, so the first is here, we talk about the fundamental trigonometry identities, right? So the first one we called is the reciprocal and identities. You already saw those one before because when we defined like a secant, cosecant, so we said like a cosecant is really is just 1 over sine. That's what we call it is the reciprocals here. Okay, so that's why, for the whole thing, we only need sine, cosines, right? Because other, you can always find it. Okay, so let's start here. So we know the cosecant axis here, right? So cosecant is just if you flip the sign, so it's 1 over what? 1 over sine. So this is the reciprocal identity we are kind of familiar with. So what is here? This is a secant x. The secant x is, we say you flip the cosines, right? So it's 1 over cosine x. And then we also said the cotangent x is equal to what? 1 over tangent x is here, right? And then we also said the tangent x here is equal to, we know that it's a sine x, cosine x. That's our basic definitions. Then the cotangent x will just be what here is a cosine x and sine x. So the first, this reciprocal identities, we use this in the previous 2 chapters. Okay, so then the next ones here, we also learned a little bit, we call this the Pythagorean identities here. So the one we already used in the previous chapter is this one. We said the sine square plus cosine square x equal to 1. So this is our first Pythagorean theory. And from this Pythagorean theory, we can derive a couple others. So for examples here, so if in here you say, hey, let me divide by cosine both sides here. So you say, okay, let's see what happens here. So if you divide by cosine square x divided by cosine square x, so what do you have here? So the first term you will have is what is sine square x over what? Cosine square x. Then cosine square plus square become 1, right? So it's equal to 1 over cosine square x. Oh, I know the sine square x over cosine square x is what? Is the tangent square x plus 1. So what is the cosine from here? We know it's the secant square x. So this is our second Pythagorean series, right? So it's a tangent square x plus 1 equal to the secant square x. This is our first one, right? So this is our first one we are kind of familiar with. We did some job, some work on that. Okay, now let's take a look at my third one here. Is also start from the sine square x plus cosine square x equal to 1. So instead of divided by the cosine, let me divide by the sine square x on the both sides. Okay, so when you divide by the sine square on both sides, so the first part, what is here? This one will just be 1 plus. Then the second part here is what? It's cosine over sine. Cosine over sine is cotangent. So this is cotangent square what? X. So what is 1 over sine? Cosecant, right? So it's a cosecant square x. So when we talk about the Pythagorean series, we have 3 identities here. But basically, the last two was derived from our basic one, the sine square plus cosine square equal to 1. So sometimes, because you know those identities here, so it will simplify your calculations, right? So we have 3 Pythagorean series identity. Then the next ones here is even and odd functions. And we did this in the previous chapter also. So the odd, we say we have odd functions here will be what is the sine. So because the sine negative x equal to the negative what? Sine x. Also, we have another ones here. We say it's a tangent negative x equal to what? Negative tangent what? X is here. So these two, of course, the reciprocal, the cosecant is the same, right? So these two, we said is odd functions here, right? Then for the even function, so we know what is the even cosine negative x equal to the cosine what? X. So we know this is our even function. Like I said, the remaining 3 is follow the same as these 3 here, right? Okay, so if you want to see the odd, then the cosecant is odd, and the cotangent is odd, the secant is even, right? So it's the same thing. So the next thing here is we call it the cofunctions here. The cofunctions, what is the cofunctions here? Let me write out one for the sines here, right? So sine pi over 2 minus cos minus x is equal to what? Is equal to cosine x here. Okay, what's that mean? What is mean? Like, okay, so what that mean is okay, so it's the cofunctions here, right? Let me kind of do the graph for you. Okay, so I know sines, right? So we know the sine is like this, right? And then we also know the cosine here. Cosine is like what? It's like this, right? So this is, okay, so I need to do the little bit careful when I do the here. Okay, cosine here. Okay, so the cosine, okay, so the cosine is like this. Okay, okay, so cosine 9. Okay, so here. Okay, so here, let's not write this one here. Okay, cosine will be 1 to 20. This is pi over 2, so it's correct. This I need to be careful. Then this one is pi. Okay. Yeah, so it's a cosine, like something like this, right? So as you can see, if you kind of continuous here, so we know the cosines here, right? So if you look at this part, okay, so if you look at this part of a cosine, right? So really, it's just same like a sine. They just shift what? They shift the pi over 2, right? So that's why we say those are the cofunction. So it's a pi over 2 minus x will be equal to the cosine x here because they shift the pi over 2. So they will become the same functions here. So the same ways here, I can write the cosine pi over 2 minus x is equal to what? The sine x here. So the same thing, I know the tangent is pi over 2 minus x will be equal to the cotangent x. And then the same ways here, the cotangent pi over 2 minus x is equal to the tangent x. Because the graph is, just like here, you shift the right, shift the left. So when the cosine is here, right, it's the same like just the sine, you shift to the left, pi over 2. Or you can say, the sine seems like you just shift to the right, pi over 2 here. Okay, then here, the second pi over 2 minus x is the same thing as what? Cosecant x, right? Then the cosecant pi over 2 minus x is equal to what? Secant x here. So that's what we call this, the co-function identity, because if you look at the graph, you look at the tangent, cotangent is the same, right? The tangent, cotangents, right? So if you do like this, okay, so this is my tangents, right? So this is my tangent, this is my tangents, right? So this is my tangent, okay? So if you take a look at the cotangents, right? So what is a cotangent? Cotangents go like this, right? So cotangents go like this here. So the same ways here, right? So cotangents go like this. So if you shift, right? So like here, if you shift like a pi over 2, it will become the, will become the tangents here. So that's why it's a pi over 2. Okay, so now this is the first set of the identities. All right, so we already learned some of them from the previous chapters here. Okay, now let's take a look. How do I use those identities, try to prove it? So the first thing here, let's say, hey, simplify these expressions here. Okay, so let's take a look here. So in here, I can say, okay, so this is a cosine t plus tangent t sine t. Okay, so I will just say this is a cosine t. So what is the tangent t? Tangent is sine t plus sine t and cosine t, right? And then times sine t. So here really is test your algebra skill. So this is a cosine t, then plus what is here? This is a cosine t. Sine times sine is what is sine square t. Okay, so now you want to combine. So what do you need to do? You need to find the common denominators, right? So the common denominator will be the cosine t's here. Okay, so now here, this is a cosine. And then you want to find the common denominator cosine t. So what do you have to put in here? You times another cosine, right? So it's cosine square t. So this one is already have a cosine t. So your numerator is not a change, it's a sine square t. So now I know I can combine the cosine square plus sine square. It's a Pythagorean identity, so it's 1. So 1 over cosine is what? Is the second t by the reciprocal, right? So that's why I can simplify this one to the seconds here, okay? And then the next ones here, let's try to simplify this one to see we'll be able to simplify it or not. Okay, so for these ones here, the first things here, you want to add two fractions. So we always need to do what? Find the what? Common denominator. So the common denominator here will just be cosine theta, 1 plus sine theta. And then here will be the cosine theta times 1 plus sine theta, right? So here's the cosine theta, you times 1 plus theta. So what do you hear? You need to have a sine theta times 1 plus sine theta, right? And then here for the common denominator, original, you have 1 plus sine theta. You have a cosine theta. So what do you need to times here? You need to times another cosine theta, right? That's how do we find the common denominator. Okay, so now let's see here. This is a cosine theta, 1 plus sine theta. Then plus, this is a cosine theta, 1 plus sine theta. Then you FOIL it. So this is a sine theta plus sine square theta. Cosine is what? Cosine what? Square theta. Okay, so far so good. Now, because they have a common denominator, I can just add the numerators, right? So this is a sine theta. So this is a sine theta plus sine square theta plus cosine square theta. Then you say, oh, I see here. This is the Pythagorean identity, sine square plus cosine square equal to what? Equal to 1, right? All right, so let's see here. So that's why my function will become, this is a cosine theta, this is 1 plus sine theta. And so here, this is sine theta plus 1, right? Oh, sine theta plus 1 and 1 plus sine theta are the same thing. So I can cancels, right? Okay, so now what I have here, I have 1 over cosine theta. From the reciprocal, what is 1 over cosine theta? Is the secant theta, right? Okay, so this is how do we, if you give me a right equation, left equation, this is how do we simplify it, how to, if you right now we say, hey, use those identity, I can try to prove the trigonometry identities here. So I'm going to use the example number 3, try to demonstrate those guidelines we can, okay? So the guidelines, so of course you can do many different way you want, right? So the typical, the number 1s here is start with one side. Okay, so of course, right? So of course you want to start with the side is a little bit more complicated than other side. So your goal is try to simplify the side, right? So your goal is try to simplify your goals here is to simplify the side you select, right? And hope it will match the other side, right? Okay, so let's see here what that means here. So like example number 3 is here. So I consider this equation I want to prove, all right? So in here, looks like this side is a little bit more complicated than this side, right? So I say, okay, I will choose, okay, so I will choose the left-hand side. So I will say cosine theta and secant theta minus cosine theta. And my goal is to manipulate this side and hopefully will match my right-hand side, right? So that's what I mean, step number 1 here, okay? Now the step number 2, my goal is try to simplify, right? So the step number 2 here, I will say, use your algebra skill. So like you need to know probably how to factor, how to FOIL, those things, use your algebra skill and the known identity. Okay, so you want to think about, can I use my algebra skill to manipulate this one then by applying some known identities, the one I wrote at the beginning of the class, right? So in the beginning of the set videos here. Okay, so now like first things here, let's say, okay, algebra skill, what I'm going to do, I'm going to FOILs, right? So I said, okay, let me go to FOIL. So this will be the cosine theta and the secant theta minus cosine is cosine square theta. Then you look, you say, hey, my right-hand side is sine squares, right? Okay, so I want to manipulate it. So let's see what the known identity I have. So this is cosine theta. Oh, I see these numbers here, the seconds here. So I know I can use reciprocal, right? The second will be what is 1 over cosine theta minus cosine square theta. So from here to here, what I'm doing, I'm using the reciprocal, right? Identities, right? So we use it with reciprocal identity because the secant is 1 over cosine. Then take a look. Excuse me. So take a look, cosine, what happened? Cancel. So you have 1 minus cosine square theta. Okay, then by the Pythagoreans here, I know the sine square theta plus cosine square theta equal to 1, right? So equal to 1. So you move the theta. So you move the cosine theta. So you say cosine theta minus cosine theta, both sides. So what do you have here? So you get the sine square theta is equal to the 1 minus cosine square theta. So 1 minus cosine square theta will equal to what? Sine what? Will be equal to the sine square theta, right? So from here to here is the Pythagoreans, right? So you see Pythagorean identities here. So what is the cosine theta? The cosine theta is equal to my right-hand side. So I proved, right? So I done here because it's I started out with my left-hand side and I end with my right-hand side here, right? That's good. Let's take a look at next one here. So I want to verify these identities here. Remember, right? So so this is what we said, start out with right scale. Then the third rule here is you don't have to do it, right? Okay. So like in here, you probably the useful hint, you can convert to cosine or sine, okay? If, if you are stuck. So convert to the sine cosine probably will, help you, to solve it. It doesn't have to be, it's just some recommended steps here. Okay, so now let's take a look at the problem number 4 here. So problem number 4, well, you looks like your right-hand side is a little bit more complicated than the left-hand side. So maybe right now I say, okay, now I'm going to start out with my right-hand side here, right? So I will say this is 1 minus sine x minus 1 plus sine x. So I'm going to start out with my right-hand side to see I will be able to manipulate and become to my left-hand side. Okay, so every time when you see you want to combine the fractions, so what do you need to do here? Don't forget you need to what? Common denominator. So this is 1 minus sine x times 1 plus sine x. So this is 1 minus sine x times 1 plus sine x. Correct? Okay, so this is original, it's 1 minus sine x here. So you need to have 1 plus sine x here. Original is 1 plus sine x. Your common denominator is 1 minus sine x times 1 plus sine x. So here you need to have 1 minus sine x. Okay, so now you can combine. So your common denominator, this is 1 minus sine x times 1 plus sine x here. So this, be careful, right? So this is 1 minus sine x minus 1. So basically, if you write this way, probably will be better. So you will not mess up the, the negative or positive sign. So 1 minus sine x times 1 plus sine x is what? Is 1 square minus sine square x. So from here to here, what I did, I used the factor formula a minus b times a plus b is equal to what? A squared minus b squared, right? This is your algebra skill. So now here, this is 1 plus sine x minus 1 minus is plus sine x here. Okay, so now here the minus 1, positive 1 can cancel. All right, so now take a look here. So I'm moving up here. So this is 1 minus sine square x. And then the top going to be 2 sine x here. You check your left-hand side. Well, 2 is pretty good. So it looks like I already have a 2. So I need to match the other. Then I know the 1 minus sine square x equal to what? Equal to the cosine square x. Why? Is by the Pythagorean, right? So we know this is a very popular Pythagorean series. Probably is the most popular Pythagorean theory in the trig is the sine square x plus cosine square x equal to 1, right? So if you have the 1 minus, so if you minus sine square x minus sine square x both sides, so you will get a cosine square x equal to the 1 minus sine square x. So that's why in here I can write it into the cosine square x here. Let me erase it and write it better. Okay, so that's why you can get this is a cosine square x. Now this is 2 sine x here, right? So by the Pythagorean. Okay, so now I can, okay, because I need to have a tangent. So I know this is sine x over cosine x, right? Then because this is cosine, so it's a cosine times cosine x here. All right, so now this part, sine over cosine is what? Sine over cosine is a tangent x. So this part 1 over cosine is what? Is secant, right? Secant x. Da. So I got my answers here, right? So that will be what? Is 2 tangent x secant x. So this is equal to my left-hand side. So I proved. Right, so I finished the proof. So the procedure is really pretty simple, but you just need to kind of very familiar with those identity, then you'll be able to switch around. See here. Okay, so let's take a look. One more problem, the last problem for this one. See here. Okay, so they want to choose, they want to see, verify this one, 1 plus cosine theta over cosine theta equal to tangent square theta and over secant square theta minus 1. Well, let's see here. So it looks like probably this side is a little bit more complicated than the other side, right? So let's see, maybe we can change one, right? So let's see here. Okay, so this is a tangent, okay? Tangent square theta, this is the secant square, not a square. So here, this is what? So this will be the secant theta minus 1. Okay, so every time you see the tangent square, probably you're going to use what? You're going to use the Pythagorean series, right? So we know the 1 plus tangent square theta equal to what? Equal to the secant square theta, right? So the tangent theta, what I can change it to? The tangent, so if you minus 1, so I can do this is a tangent square theta equal to the secant square theta minus 1. So I can change this one to the secant square theta minus 1. Correct? So I can change it to the secant square theta minus 1. And then here, this is the secant theta minus 1. Okay, so now I'm going to factor. So here I'm using the same factors here. So I know a squared minus b squared, just like the one we used before. This will be equal to the a minus b, a plus b here, right? So now the secant square, so I can say this is the secant theta minus 1 times the secant theta plus 1, right? Now here you have a secant theta minus 1. But I can cancel. Ooh, this is pretty good, all right? So secant theta minus 1 cancel. So what I have here, I have a secant theta plus 1. Well, now you check to see match your left-hand side or not. Not really yet, but I know the secant, we got the potential because the secant is 1 over cosine. So what is this property? is the reciprocal properties, right? So plus 1. Now I'm going to do the common denominator again. So this is a cosine theta is a common denominator. So this is 1. This is the one you put a denominator. So what do you need to have here? Cosine theta. Now you have the common denominator, and you can combine this 1 plus cosine theta. Ha, this is equal to my left-hand side, right? So I proved it, right? Okay, so those are the like a few problems, and just try to get you started with this, the trig identities. So in the remaining few sections, we're going to graduate to introduce more and more trig identities. So then you'll be get to familiar with that. All right, so that's it. So for this section, so we basically talk about the four basic identities: the reciprocal, Pythagorean, even odd function, and the co-functions here. Okay, and that's it. And hope you get a good start for the analytical geometries. And then the next ones here, we're going to talk about another identities. We call this add, the addition, and the subtractions identities here. All right, that's it. And it's nice to talk to you, and looking forward to work with you for our next videos here. Okay.